We're going to wait about 2 minutes and start on time for the remote participants. All right, our first presentation of this session is going to be detecting DGA botnets using DNS traffic from Dr. Han Zhang.
Thank you. I'm Han Zhang from Salesforce, and this work is what I did before I graduated, and currently I'm still contributing to this project in my spare time. So today's talk will talk about some introduction and why we use DNS traffic to detect DGA botnets, our methodology, deployment, and some interesting discussions, and also some future work. So in the past years, we have lots of attacks, every kind of attack, DDoS, spamming, scanning, every attack. So you may wonder, why do we have these attacks and where they are from? So in this table, we list some of botnet examples can be used to perform all of these attacks. Actually, building a botnet is not as hard as you think. You can easily buy some botnet from underground market, and it is not expensive. For example, 1,000 botnet only cost $20 in North America and Europe. And in Asia and Africa, it's even cheaper, like $10. But on the other hand, we lost lots of money every single year. So I guess most of you have idea of what is a botnet, but I do want to spend some time to discuss what a botnet is, and especially what is DGA botnet. So basically, botnet is a network of infected computers, and we call this infected computer as bot. These bots can be distributed into multiple networks, but they do follow the same commands from the bot master. We call this command and control channels. So it plays a very important role in botnets. That is the way how bot master talks to the bots. Many protocols have been used as CNC channels. For example, in the very, very early years, IRC was used. Both bot master and bots join the same IRC chat room, and they can share commands and the results there. And after that, P2P protocols were used. And the very popular protocol used by botnet is HTTP. So the way it works is the bot master registers a domain, for example, commands.com, and then it builds a web page there and publish the commands there. The bots will periodically query this website to fetch the commands. In the early years, this domain was hard-coded in the bot binary. So as you can imagine, we can extract this hard-coded domain by our security experts. And once we do that, we can block the domain. So this is a kind of single point of failure for the botnets. So the bot master decided to involve this. So instead of using a single domain hard-coded in the bot binary, they use algorithm named domain generation algorithm. In this case, they can dynamically generate a long list of domains by using this DGA. The seed can be timestamped or some other input. But the problem is the bot master do not need to register all of them. They can only register 1 or 2 of them. But on the other hand, the botnets, the bots, do not know which 1 or 2 are registered by the bot master. They have to query all of these domains one by one. For example, they go to the first, and it is not registered. And then the second, still no luck. And when they hit the third one, which is the registered, they can talk to the CNC server and get the commands. So now let me talk about why do we want to use DNS traffic to detect this DJA bot. First of all, the bot master and the botnets have to query IP addresses for the domains. They have to use the DNS traffic. And the more important thing is the botnets have very different, very unique DNS traffic pattern compared to the legitimate host. I will cover all of these unique patterns in my later slide. Another reason is compared to the other traffic, the DNS traffic is kind of small, so we can apply some complex algorithms on them. Another important reason is because we detect these bots based on DNS traffic, so there is a chance we can block their traffic even before they perform any attack. So obviously, we are not the first to use DNS traffic to detect DJA bots. There are some previous work, but they have some limitations here. One limitation is they require a group of bots, several bots, to be existed in the same network. The assumption is because these bots belong to the same botnet, they will have similar behaviors. They will query similar set of DJA domains. But because they require multiple bots, they have to collect DNS traffic from multiple networks because in a single network, there may be only one or two bots there. So there are some privacy issues to share DNS traffic between multiple networks, or they can use some upper-level DNS traffic like TLD traffic, but this traffic is very hard to access by most of network administrators. So as a network admin, what I care about is whether I can detect botnets in my local network. If I can detect some botnets for other networks, so that is extra credit. So what we need is a system can detect single bot using DNS traffic by only capturing the traffic from single enterprise network. So the ideas behind our tool, bot digger, is there are some unique DNS traffic patterns for the DJA bots. We call them quantity evidence, temporal evidence, and linguistic evidence. So I will not go to the detail in this slide, but I will talk about them in details in the later slides. So here is an overview of our system. The input is DNS traffic. The first step is we use a set of filters to filter out the non-suspicious domains. For example, the domains do not have a valid TLD, or some very popular domains like Google or Yahoo.com, we use some whitelist. And then we have the suspicious NX domains. So we focus on NX domains because most of the DJ domains are not registered. And then this suspicious set of NX domains go to a chain of evidences. After that, we will have detected bots and a set of NX domains for DJA botnets. The final two steps is we locate the specific CNC IP addresses and domains and do some aggregation to reduce false positives. So the first evidence we use is quantity evidence. The assumption here is most of the hosts in a local network are legitimate, so they do not send a large number of suspicious NX domains. On the other hand, because the botnets do not know which domain is registered by the bot master, they have to query lots of NX domains. To validate this assumption, we extract 1 hour legitimate traffic from our university and combine it with a known DJA bot. So this figure shows the CDF for the number of suspicious NX domains. And the red dot is the bot. So from this figure, we can clearly see the bot is an outlier in terms of the number of suspicious NX domains. The next evidence we use is temporary evidence. So that means because the bots do not know which one is registered, and they want to talk to the CNC domain as quickly as possible. So in the beginning, they send lots of queries for suspicious NX domains. But once they find which one is registered and they fetch the commands, they do not have to send any more suspicious NX domains. And we reuse the same 1 hour combined traffic as previous slide and show the results here to validate this assumption. The X line in the figure is the timeline by minute from 0 to 60 minutes. And the y-axis is the number of suspicious X domains. And from this figure, we can also clearly see there's a spike for the bot there. So one thing I want to say here is by only using this single evidence is not good enough to detect a DJ bot. So that's why we combine several evidences together. The next evidence we use is linguistic evidence. So that means the DJ and NX domains have very similar linguistic attributes, and also CNC domains have similar linguistic attributes. So by linguistic attributes, I mean that can be they have similar length of second-level domain, or they have similar entropy to calculate the randomness of a string, and how many directional words they have in their domain, something like this. Actually, we use 23 linguistic attributes for this evidence. The left figure shows an example of a real DJ bot. So from this figure, you can see most of the X domains are random. So it doesn't make sense to register these domains. Another thing we noticed is the CNC domain also looks random, very similar as the X domains there. So once we apply these filters and also 3 evidences, we were able to detect the bots and also a set of DJA NX domains. But we want to take one more step to detect the specific CNC domains and its IP addresses. And then we can share these results to more networks or institutions. They can use them as blacklist. So now we have a set of NX domains. To detect the specific CNC domains, the assumption is the CNC domain also have similar linguistic attributes as the set of NX domains. So we build some signatures based on the detect set of NX domains and applying it to all the successfully resolved domains during a time window to extract the CNC domain candidates. But still, there are some false positives there, and there are a few legitimate domains were labeled as CNC domain candidates. So that's why we want to go back to use some historical information. So we look for the IP addresses that are mapped to more than 10, actually some threshold can set. We use 10, more than 10 CNC domain candidates in the past 30 days to detect the specific CNC domain and IP address. And here is an example of what we detected when we run our bot digger. And as we can see here, most of the domains, or all of them, are random. So here is some evaluation of algorithm. To evaluate the true positive, we use 2 sets of DJ bots. One is a set of 140 real Kraken botnets we obtained from Georgia Tech. And another set is the simulated 1,000 configured botnets. The different lines in the figures show different parameters we use in our system. So I will not go to the details of these parameters. The takeaway message from here is our bot digger can detect 100% of Kraken and more than 99% of configured bots. So I understand that these 2 botnets are very old. They have been out there for more than 10 years. So I will show some more recent result for other botnets in the later discussion section. Another thing we want to evaluate is the false positive. To do this, we captured 1 week of DNS traffic from Colorado State University, and we run our system there. 33 out of about 20,000 hosts were labeled as bot candidates. And then we check these hosts on VersaTotal and trusted source to see whether they are real bots or not. And the results gave us about 11 hosts were false positive, which is not bad results. So I have spent 10 minutes talking about this research, these experiments. So the question is whether we can use this system in reality in the real network. And we do deploy our systems in multiple universities and companies. Currently, the bot digger is deployed at Colorado State University, USC, ISI, Lino, and Northrop. The bot digger is open source on GitHub, so everybody is welcome to use it. It is very easy to deploy. There are two modes there. You can run it in real time. You can mirror port DNS traffic to some box and run the bot digger there to detect the DJA bots in real time. Or if you have some PCAP files, you can run our bot digger offline and detect some bots there. We deployed bot digger at CSU since December last year. And this tool is currently operated by NetSite group at CSU. And we have more than 20,000 users there. And I will go to the detected CNC domains in the later slides. Here is how we deploy this system at CSU. At CSU, we have 4 recursive DNS servers. For some technical limitations, not all of the traffic from these 4 servers can be mirror ported to the same box. So we run 2 separate boxes, and each of them have a bot digger on it. Another deployment we have is at ISI, Lino, and Northrop. This is operated by Calvin at USC. The way it works is we generated some bot lists at CSU, and then we share them, the list with Calvin. So he can check whether this bot list match some domains or IP addresses in their PCAP files. Or I think he also run bot digger on their PCAP files. So these are the 2 ways they run bot digger. And we do have some results from them. They detected, between February and April this year, they detected 29 distinct domains from 2 IP addresses, resolving to 2 IP addresses. And they also find 1 match for both of CSU and ISI. Now I'm going to some interesting results for discussion. So as I mentioned earlier, we use correction and configure to evaluate our system, and they have been used for 10 years. So the question is whether botnets can be detected by bot digger, or some recent smart botnets can be detected. And the answer is yes. So we go back to the results manually to the detected CNC IP addresses. And we do find some recent botnets. For example, we detected 5 CNC IP addresses for Nicker. Nicker has been used since 2012. It has a bad reputation to distribute some other botnets. And early this year, the researchers found Nicker was responsible for distributing some ransomware. So the takeaway message from this slide is bot digger can detect both of old-fashioned botnet and also recent botnets. The next question is whether botnet can detect new CNC domains. And as we run bot digger at CSU for more than 6 months, and we detected about 3,600 CNC domains. We check all of these domains on VirtuTotal using the REST API to see whether they are labeled as malicious or related to botnet. And we found that about 2,700 were labeled as malicious. So that means another 1,100 were not labeled. But we believe these 1,100 domains were related to a botnet because of 2 reasons. The first one is these domains were mapped to the detected CNC IP addresses. And also, all of them are random looking, very similar as what we detected for the other 2,700 domains there. So we believe they are related to suspicious and botnets. So the takeaway message from this slide is bot digger can detect some new CNC domains. The next question is, bot digger seems to perform well to detect existing botnets. So can botnet detect some new botnets or smart botnets, right? So we show a specific example here, which is the botnet, not botnet. some suspicious hosts we detected. So from this figure, we can see the left one are the X domains detected by bot digger. And there are some typos there. So my guess is they try to avoid the legitimate registered domains. And then they give us the right one for the CNC domain. But actually, it is not a CNC domain. We go to this web page. It is trying to sell some replica bags, shoes for Louis Vuitton. And when we click on it, it redirects us to the real Louis Vuitton website. So that is not a CNC domain, but the takeaway message is it shows the capability of bot digger is able to detect random-looking domains and also some botnets that could generate the DJA domains using a set of dictionary words, which can be used by more smarter botnets in the future. Okay, so here are some false positives, and I have to skip this. And there are some future work we want to do. We want to deploy bot digger at more universities, and again, bot digger is open source, it's free, and we are generating the bot list every single day. And we are looking for more opportunities. You can subscribe the bot list from us, and we are very willing to share our results. And if you have any questions, you can contact us there. And I'd love to take some questions.
Paul Hoffman from ICANN. You skipped the one bit that I wanted, which was the last slide on false positives. Or,
Sure.
Well, yeah. So it seems possible that, bot digger works now, finds a lot of things, that's great. If it's very successful, the bot programs will also get successful and figure out that you're doing this, at which point I think they're going to send you into a pit of false positives. Have you thought about how to deal with that in the future, or are you still pretty much keeping up with the current stuff?
It's a good question. So there are a few ways they can trick our system. And one is they can query the domains very slowly because we focus on a specific time window. But in that case, we raise the bar for the botnets.
Sure.
Right? And they can generate some of these similar false positives to trick our system. So in my thinking, our next step to reduce the false positives is we can build more intelligent component for linguistic attributes.
Okay.
To field these false positives.
Okay.
But that is definitely our next step work.
Right. I wasn't thinking it was needed now. I was just worried that,
Right.
They have more financial incentive to break things than you, so that, could you stay ahead? And it sounds like the answer is yes, you've thought about that. So great.
Right. Yeah.
Thanks.
Thank you.
All right, Rod Rasmussen, wear my APWG hat right now. Thank you for the presentation. It's good to see people doing this kind of work and putting it out in open source so that we get it out from a lot of the people who are doing this kind of work and much more sophisticated work, but kind of bearing it into products. Just on the point that you were talking about with dictionary words and things like that, there's a lot of that already in play. I know we've observed things going beyond dictionary words. Actually, one of the things that's fun to do with this is detect the dictionaries themselves that they're using, right? So you can, like, factory in this one was an interesting one, right? So you can actually try and figure out what the bad guys are doing. So there's some good work that's been done on that front. But we're seeing the DGA folks doing things really smart. Like we saw one that used the Declaration of Independence as a seed, as it were.
Right.
Right.
It can be very smart.
Yeah. So, but that's already in the wild, right? So, I think that there's a lot of work that's going on in this space, but it's good to get something out there where people can actually take a look and kick the tires, so to speak, of how this is being done. Are you there is a trust group that actually looks at DGAs. Are you tied into that trust group? Okay, we'll talk about it offline.
I'm not. I don't think so. But
okay, all right. Well, for those people who are looking at DGAs and trying to detect them and things like that, there's actually a pretty good. It goes up and down. There's a trust group with that. So there's if you know the trust group folks and things like that, or want to reach out to people and get yourself involved with that, then things like this can benefit from that kind of collaboration that's going on there. But thanks for the presentation.
Oh, thank you. Yeah, we are looking for more opportunities to share our generated bot list. Okay, thank you.
Our next speaker is Ed Lewis.
Good noon. It's now noon, right? I want to talk about a topic that comes up as a byproduct of doing research. This is not about research that's being done. This is something that comes up in things we do all the time. I'll leave it on there. And I probably should explain this through the story of what led me to submit this abstract. One of my colleagues has been measuring the size of key sets in the DNS for the KSK rollover, by the way, which we are postponing in case you haven't heard that. I mention that because now I can charge my trip to that project. But this has been actually a long-standing project here. A bunch of us who've been doing DNSSEC for a while try to look at how do operators implement DNSSEC. And one of the popular things is just look at the size of the key sets out there. This thing keeps moving on me. I swear. Okay, it doesn't matter. The slides really don't matter much here. This is more a talk about talking. In fact, I'm not even look at the slides. So what happened here is I got the email, and someone says, look, this domain name has a lot of keys in it right now. And it's like, well, it's too many. Too many keys are there. It shouldn't be that big. It doesn't make sense for it to be that big. And it belongs to this domain name, and, well, it's kind of awkward here because at this point, you could probably try to figure out who the owner of that name is out there, but it's kind of awkward to say, hey, you're doing something wrong. We just want, we got to fix something here. Because there are a couple of things that in this case that are frustrating. One is, what is too many keys? I mean, that's kind of a subjective thing out there. Also, when you are trying to reach into some parts of the DNS, you don't have a good way to contact that person. I said when I was describing this to other people, a couple of flashbacks come to my mind in this. And I had a situation one time where I found an issue with an operator's workings, but they didn't speak English. And I couldn't communicate with them, but I figured out someone else could do that as a go-between. And what happened there was I tried to be discreet about this. I don't want to really point a finger that you're doing the wrong thing publicly, because you may not be. But the go-between person then blogged all about the fact that he got involved with this little rescue of something out there. Another flashback that occurred in looking at this problem that I started out talking about was a couple years earlier, we also, my same colleague and I looked at this other operator, and they had too many keys. And we were using that, again, preparing for the KSK rollover, which we were postponing. And we didn't know what to do here because we weren't really allowed we had nothing that says we were allowed to help this group out. Sometimes helping is seen as interference or pretending that we have an SLA or something like that. It comes across too formal. What happened then that operator then fell over a week later. And we felt really guilty because we knew that they weren't really working correctly. We felt bad that we didn't warn them that they fell over. And in this situation, we eventually got to meet the operator face to face. The operator had come out to the manual saying we had a problem. It turned out what we saw there wasn't the cause, so we were a little relieved it wasn't what we saw caused their failing. So we weren't really negligent in not telling them. But when we sat down with this person face to face at a meeting, we found out that the engagement was really helpful. They were really appreciative of whatever expertise, whatever kind of hints or help they can get. But again, this was the barrier, was that we thought we weren't allowed to go talk to them. So coming back to the original story, again, we have this domain name, and this domain name's in a place that's, we can't really reach them. We can't really even reach the registry that they're registered with because, again, we don't want to be seen as interfering, and it gets kind of messy. So, this happens often. You're an operator, you're looking at a protocol, you want to know, is a protocol being implemented correctly? Are people operating it the way we expect it to be? Is it because the specifications were unclear, there is a need for tooling? You're not after operators' performance, but you notice an operator is having an issue. So what do? And it gets frustrating because we've seen the situation where we just don't know how to reach that person, that individual organization without embarrassing someone. So this is where So this is where this slide comes in. Like, is there room for work here? DNS OARC, Operations and Research Center. We're about research. The thing that came to mind was, is it possible for DNS OARC to play a role here? Maybe this is more of an AGM question than it is a general question, but I want to get as much opinion as possible. What if there was a way for researchers to say to some group of folks, say, look, I'm seeing something here which I think might be of interest to the operator. We don't intend to look for this, but can we get people to take a look at this, verify, vet, and make sure that this really is a legitimate thing to bring up to the operator? That's one thing. Maybe not get involved with the explanation of it, but at least introduce to the operator that the person is bringing this up is doing this in goodness. We're not trying to say that you're working badly or doing anything the wrong way. And in a way that's a very more softer approach than saying, I'm from, in our case, ican.org. Now, because it's from us, I feel a little guilty that I might be direct. So the question I want to open up to the mic for folks to have opinions on is, what do you think is the best way to handle a situation you see that should be brought to an operator's attention, but you don't have a direct relationship with them, or you'd rather have it go through a third party and have it checked out by other folks? So I'd like to really want to get a discussion about that and get some opinions from folks that are listening and see if there is something here that we could pursue, or if you think this is just me going crazy. So I'll leave it to comments. I'm going crazy, I guess. So,
Warren Kamari, I guess I'm a little unsure why you're asking us. As far as I can see, or as far as I can guess, most people here would be perfectly fine with you going and talking to the operator directly, right? Call up the dude and be like, hey, just so you know, you've got this thing, it seems a little weird. As far as I can see, the only people who might be uncomfortable with this is ICANN constituents. So I think that, it's fine to ask us. I'm happy to provide opinions. I have opinions on everything. But I think that the people who actually are the ones who are being potentially sort of the sticky wicket is a different constituency, and asking them and saying, this seems like something that would be useful to make everything better. Does anyone have an issue would be a good step. Maybe.
Hi, I'm Daniel. No, I think you raised something very valid. In my talk, I talked about this, hyperactive primary query person, and actually getting to them was not so easy just to get the contact information. I was in a privileged position to do that, and that's why they probably responded to me. So I can emphasize with what you're saying. Thinking off the top of my head, maybe there is a space here for doing some database where you can put observations that would be keyed maybe on IP address to take it out of the domain space. I'm basically saying, somebody puts up this database, and I can put a sort of a notify thing in for my own IP addresses, and then whenever somebody has to say something about the particular range of addresses, it gets to me. That's as neutral as you can make it. It's obviously it's open to some DOS vectors, but maybe something simple like that would actually work, and you would reach the people who are willing to listen, and you would not reach the people who are not willing to listen, and then try to make it gain momentum, slowly. I think that just a weird idea I had in the last minute or so.
John O'Brien, University of Pennsylvania. 2 comments. The first echoes Daniel's, is that any of us who control name or number resources have contact information associated with those resources, the purpose of which is to receive various kinds of notifications about things that are off about our operations or what our users are doing. And each operator has to make their own decision about how much to pay attention to notifications that come in that way, and we're free to ignore them. I say that as someone who's on the hostmaster alias for the university. The second comment I'll make is that, at least from my perspective, one of the most useful things is a way to see what you see, typically in the form of a self-test. This works really well for a TLS, for example, with things like SSL Labs. I can go to the site and say, how does this look to you? And then get a grade. It sort of gamifies the experience. And then I know what to go and look at. There are some sites that provide this sort of testing for the DNS, both on the resolver side as well as the authority side. That might be something that you would want to look at doing even officially as ICANN, to say, here's ICANN's best practices for the DNS to the extent that they have support in the standards or not, and how does this look? And then those who are interested in conforming to that can go and just see what you see.
My name is Andrew Sullivan. One of the things that I'm not sure what you're saying here is whether these are specific cases where you want to be able to reach out to somebody, or whether you're talking about a pattern that you're seeing. Because it seems to me that it is reasonable for OARC to have a position about, oh, here's a thing that we're seeing out there, and here's a test that you can test your network in order to do this. I think it's probably quite a different thing to have people sort of reaching out to operators who apparently don't know what they're doing and don't especially care to know, to tell them, clean up your network. We've had occasional opportunities to talk with people who, want to form the internet police force and general good manners, committee. And I just think that that's hopeless, because the people who care about this will monitor their own network, and the people who don't, no amount of correction is going to help. So if what you're suggesting in that last bullet is, oh, well, OARC should, put up test cases for this and so on, I think OARC has done that historically, and I don't know whether the membership would want to continue to support that, but I wouldn't be too surprised. But if really this is a sort of clearinghouse of dummies on the internet, I don't know that that's a good idea, because it seems to me, first of all, that the universe is going to make a lot of those, and if we start that task, we're going to run out of money before we run out of dummies.
Yeah, to answer the first round of questions, I really don't mean this to be ICANN specific, because I've had this in my mind from previous other jobs where you want to reach to someone over there, and there's just a barrier, like either you can't find good contact information, even if you know how to look. So it's not just that, but also what Andrew's saying too is, the reason why I'm not really sure what to do here is I don't know what's a good scalable solution. It's not certain that, what do we collect here? I've been through discussions about collecting attack data and so on, where that falls apart because you really can't disclose what's happening in real live action with attacks and security incidents. This is just meant, what I'm looking for here is more of an introduction, a formal introduction where DNS OARC can brand itself as we're a research area, we're neutral, we're not enforcing any way of doing, we're not protocol police. And they're just, or maybe just even opening up an introduction somewhere. And, again, is it, in this terms of describing the problem that comes here, I've been on the other end where I've seen reports of badness on my network. Well, what are you talking about? I mean, so I get all that. So this would all have to be packaged up somehow for this to make sense. So that's why I'm still searching for what to do here. So, yeah.
So Warren Kumari again, I might have worded my earlier thing poorly. I want to make it clear, I think that it's perfectly fine for ICANN to go along and talk to people directly if they find issues. On the Rolodex type thing, how sure are you want something like a formal introduction? I think what you most likely probably want, and I might be wrong, is to be able to send email to the list being like, does anybody know the operator at foo? I'm trying to get hold of the guy there. Because often for these sorts of things, or at least the sorts of things I think you're talking about, an informal thing is much, much better, right? Like, I'm some guy, I saw this issue, did you know you have it? Often works a lot better than, this comes through this organization and we've been vetted to do stuff. Just a thought.
Okay. You want to cut the mic lines at least, right? One of the times that sometimes language is the barrier. So, I mean, that's what I mean by Rolodex. Maybe, for example, I was trying to reach somebody in West Africa, and I know that's a French heritage, so I reached out to a French-speaking colleague. Having that, just so we have a core of people that can at least say something, and then it goes into whatever. So sorry. Good.
I think that Warrant is right. Today we have seen at least 2 examples where, like, informal saying, hey, this seems weird, works. One was the first guy which was sending thousands of priming queries. The second one was Akamai, and in both cases it was, okay, we didn't know that it's wrong, so please do talk to the people.
Yeah.
At least the big ones. Of course, we can't fix everything, but if we fix Akamai, it will certainly help, and so on. So there is some common sense lines.
So we have time for this last person, or should we just tell him to sit down? Go ahead.
Okay, I'll sit down.
Go ahead.
I think we have time.
Okay. I was just going to say that I think informal contact is good. If you, as an ICANN person, can do it, I'm sure you can always find some stooge in this room to act on your behalf. And secondly, on tools. There are lots of tools out there that are testing DNS settings and setups of domains. Many of these tools are bad. So adding another tool that is with somebody's opinion on what is right is going to cause lots of arguments. So I would discourage any more tools.
Yeah, I don't think tooling, it's all subjective. When I say too many keys was the example, I mean too many's.
Too many keys, or is it too big of a key set? That's 2 different questions.
Because a lot of times operators have a good answer for why they have it is the way they are. So
Yeah.
it's definitely not a hard and fast rule that you're wrong. Yeah. Right and wrong is relative. So.
Well, you're wrong and I'm right. That's the truth.
So what's new? Thanks.
Our next speaker is Yuri Yusufovich.
Okay. First of all, Ralph from Nominal, my colleague of mine, I think introduced Nominal already, so I'm work for Nominum, and in a team that does data science and security research with the data that we receive. And today I want to talk about what we call new core domains within the team, and that there are various different names for the same phenomena, and it's the domains that you can go and buy. You know, that's oversimplification of that, but and we'll look in the traffic on that. So before I go into the details of what we've seen and what analysis we've done, what I want to talk a little bit about what my team does. We have data scientists and security researchers, and primarily looking at the DNS data that we collect from telecommunication providers, that our customers that using our DNS technology. And roughly we get more than 1 million queries per second. It's more than 100 billion per day. And it's a continuous stream of data that we have access to. And it includes both the caching data and authoritative data. Caching data has anonymized IPs, but for our purposes, it's good enough for what we need to do. And what we try to create, we create feeds that we supply back to telecoms to block a variety of attacks from botnets to amplification to DDoS, using those that use DNS as a vector of an attack. And speaking of the new core domains, we've been doing this research for more than 5 years, and it's been quite fundamental to what we do because it feeds into the many algorithms that we have downstream processing. So again, that's a very simple concept. If it's .com, that's typically something.com. If it's we have a effective TLD, that's something one level below an effective TLD. So in the case of UK, it's example.com.uk would be core domain. Why new core domains are very useful? One would assume that the new registration would suffice. And our philosophy to new core domains is that it's a lot more than just new registered domains. As the previous speaker mentioned, and we also do a lot of DGA work, that it's used, core domains are used for command and control communication. And most of this, for example, for botnets, are not resolved. They are not registered. And that is why concentrating just only okay. And concentrating only on the registered domains would not be good for security. So that's why this new core domains is a good source of information for both domain generation algorithms and for a variety of phishing attacks and other malicious users that we'll dig into. So what primary source of data we have is the caching data from telecoms, and we build algorithms that analyze them in real time. So we also have authoritative data, but the big difference between authoritative data and the caching data for our research is that we have the streams that would be from the same client IP. So we don't know what exactly this IP is. Think about it as an ID of an IP. And this allows us to see which traffic goes from in the same client, the same household in our case. And that allows us to build machine learning algorithms that give us additional insight into the correlation between the names. So what challenges, obviously, with these data sets? Whenever you have so much data and you develop algorithms that look into the data as previous speaker mentioned that there is high false positive problem. For our purposes, we address this by a variety of methods. That allows us to concentrate on actually finding the malicious use both for pre-infection and post-infection. And pre-infection, it's malware download sites, it's phishing landing destinations. For post-infection, obviously, it's command and control servers and domains used by browser hijackers as well. So there are two schools of thought of how DNS data or any data can be processed. It used to be most people did batch processing, and Hadoop is a very convenient tool to do that. And, but the problem is data these days is generated every second, and we go from 0 week to 0 day to 0 hour to 0 minutes. So in some cases, domains are used and discarded just within a few minutes. So we can't really go that path with batch processing. So we have to change our paradigm and convert to the stream thinking. So so the goal is obviously find new core domains. That's what we try to do. And originally we did use batch processing, but then we said like, okay, we want the stream processing. So there is fancy big data tools available. So why don't we just put something together in a cluster and everything will work perfectly. The problem that we don't just want to look for the new core domains, we want to extract the features along the way, which means having a large set of different counters and thresholds and to help us process it downstream. And turned out that standard tools were too heavy, and we after some experimentation, we did change to something more efficient, what we call a bicycle, but it's not a really bicycle. It's we feed on Kafka and process the data in memory and feed it back to Kafka as a stream of new core domains. So this is just a little bit of an engineer overview of the technology. And the resulting code, we also put together a dashboard that we can just have some fun with. It's not an algorithmic analysis. It's something for visual pleasure in our office where we track new core domains. So let's dig into one day of new core domains. So what we've done, we just pick a random day for the analysis, for a little bit more in-depth analysis, and it happened to be August 7th in this case. And we looked at how many new core domains we have. That's 3 million in our data. And then the methodology was, let's try to look at how many queries to these new core domains that we've seen in one single day we would observe over the following week. So the idea is how persistent these new core domains. Maybe they disappear in an hour. Maybe they are kept being queried for many days. And just a couple of simple statistics for this data set is most of the new core domains obviously did not resolve. When we plot a stream of new core domains over one day, 24 hours, there is a spike at 0 UTC, which you may guess that it's related to the DGAs that use a different day as an input into the function that calculates the domain names. So it's a natural spike in new core domains at 0 UTC. And then, since there is quite a lot of domains, 3 million, I mean, how can we analyze it quickly? So we introduced a simple threshold. How about if we take a look only at the domains that generate over 1,000 queries over 1 week? So we're still talking about new core domains that we saw within 1 day, right? But we added all queries to them over the following week, including the day that we saw it. And it turned out that there is only 3,000, a little bit more than 3,000 domains that produced any sizable traffic over the course of the week. And that allowed us to look a little bit deeper. And by the way, if you count all the queries produced by the new core domains, just these 3,000 out of 3 million produced the majority of the queries over the week. So it doesn't mean that the rest are not important. It's just we zeroed in for this analysis on the popular ones. There's a lot of different methodologies that we use at Nominom to do categorization, because the interesting question is what we can tell about them. And there is anomaly detection. We have also domain reputation system that tries to map domains to IPs and reputation. Behavioral analysis, we look at shapes of the traffic. We have correlation technology. And also we have a DGA project that takes advantage of the great work of cybersecurity reverse engineers around the globe. So quick look at the what we could classify. It turned out that when we looked at the popular core domains, 2/3 could be classified. Not only could, we actually classified them in our intelligence feeds. And about most of them are post-infection because of the DGAs, and a small slice for the pre-infection threats. Another interesting statistics is that more than half of the domains we actually blocked before we saw the first query. And it's not really magic. It's the hard work of using the algorithms that are available through some of the communities, cybersecurity communities. For Neckers, for example, you can predict the domains every 4 days. So this is an example of Neckers activity. So the ones that we saw during the first day, they're active for 96 hours. That's a known fact that Neckers domains are kept queried in the traffic for 4 days. And this is just a sample of the names. There is more interesting examples, browser hijacking. So browser hijacking is, there are different types. And on the left, there's analysis about outpouring Android.com that we saw on that day. If you search Google, you can find some articles how to get rid of this browser hijacker. But the interesting thing, it looks like it's a single domain, but it's not. We have actually a blog entry that explains this process. So there is a constant change every other day to a different domain. So the pattern looks like waves. And all of them are new core domains, just on a different day. And also, there is a pre-infection that we able to identify. This is the same algorithm that produces these domains. They all resolve because it's a pre-infection. So users have to be able to go to that web page and get the malware download or phishing attempt. And these domains use just for a single hour. And they are spread across different domains and sometimes across, across the time and sometimes across different domains during the same time. And by the way, just within 1 hour in our sample, we see more than 500 clients, unique clients querying this. Given that we see probably about 1% of the traffic, so you can calculate times 100. That's a very significant number just within an hour. So to summarize, I would like to ask, when we think about these new core domains, there is obviously quite a lot of people who didn't look into those, and Paul Vixie himself introduced a few related concepts several years ago. But the interesting question, how to classify them. And because for telecoms, when we block something, telecoms expect us to know what we block and why we block. So if we just start blocking all the new core domains, that's a slightly different story. So that the bar for precision and the low false positives or zero false positives is very high. And turned out that with a variety of techniques, those popular ones in new core domains can be successfully classified with the techniques that we use. For future research, one thing that I wanted also to mention that one of the interesting directions of the research is to look into new pseudo-new core domains, is those that are registered with USA.cc and similar services that are not technically core domains, but subdomains registered with free services. So they are also a rich source of good suspects. Questions?
I believe Matt Poundset has a update on the PGP key signing session.
Okay. Do we have a question or not? Okay.
Hello again. So we're going to be meeting back here at I believe it's 1:30 for those of you who are participating in the PGP key signing. Anyone who wants to participate should download the keyring, which is that URL is the agenda item for the PGP key signing. You could also just go to the agenda and click your way through. From the agenda item, you can download the keyring, which is that OARC 27-keyparty.asc. And then you should get the hash of the keyring to verify that it's correct. If you're very fast, you can get it downloaded and compare the keyring to the hash that's on the slide there. But for those of you who don't type 200 words per minute, I'll read out that checksum at the key signing as well, so you can do a comparison there. Once we've done that, it'll be very simple. All that anyone has to do is look into the keyring, verify their own fingerprints there, and then all you have to do is say, yes, the fingerprint or the key in that keyring is actually my key, and we don't have to do the crazy thing where every single person has to read out their fingerprint over and over again. So this is what we're doing. Please grab the keyring. I'll ask Dave to put this slide back up just before we leave for lunch, so in case anyone wants to do this then. Unless anyone has any questions, I think that's it.
So we'll be back here, right?
Yes, meeting back here at 1:30. Yes. All right, thanks very much.
Okay, I believe the next session is not going to be webcast. So we'll resume, the webcast will resume in about, I believe, about 90 minutes or so. Okay. This one is Vince Visone from AFNIC.